This is gonna be unit 4.1. This is just gonna be a practice review. No test prep, just like problems that you will see on the test. So, the first question asks, the percentage grade of a student receives on a test is modeled by g of t, where t is the number of hours spent studying for the test. Interpret g prime of 1 equals 3. So first, our independent variable, the number that's being plugged into g of t, is the number of hours spent studying for the test, and the dependent variable, which is what we're measuring, is the percentage grade a student receives on the test. So we're told to interpret g prime of 1 equals 3. That means at 1, which is our independent variable, is number of hours. So at 1 hour, the rate of change will be 3%. So let's see how we would write that out. We would say at 1 hour of studying, the grade will improve, and we can see that the derivative is positive, which means it's increasing, so we're going to say improve at a rate of 3% per hour. Alright, next question says, Mr. Bean rides his motor scooter to work some days. His distance from home can be modeled by d of t. Let's underline our independent variable. T is measured in minutes, and d of t is his distance from home. We need to evaluate d prime of 15 equals 650. So, we know 15 is the number of minutes, so at 15 minutes, the distance, which is our dependent variable, from home, and we know that our derivative is positive, so we can say that the distance from home will increasing at a rate of 650, and our dependent variable is meters per minute. And that's how we write that out. The rate at which a factory produces baseball hats can be modeled by b of t. So this is our dependent variable, where b of t is the number of hats produced per hour. This is our dependent variable, number of hats produced per hour, and t is the number of hours since the factory opens. We interpret b prime of 100. So first of all, we have our independent variable. So at 1 hour, the rate of producing hats, which is our dependent variable, let me extend this, hats, is increasing because our derivative is positive at a rate of 100 hats per hour. And that's our answer. Let's keep going. Mr. Bruss has entered the Biggest Loser contest and is hoping to lose some of those holiday calories. His weight gain or loss can be modeled by P of T, where P is measured in pounds per week. So now we have P of T. P of T represents a rate. So P prime of T will represent the rate of the rate, and we'll get into that in a second. And T is the weeks since he started his diet. So our dependent variable is the pounds per week, and T is the number of weeks. We need to interpret P prime of 4 equals negative 1. So now this is the first time where our derivative is actually negative, which means it's decreasing. So let's go ahead and start. On the 4th week, because weeks is our independent variable, the rate of weight loss, because that's our dependent variable, is decreasing now at a rate of 1 pound per week squared, or per week. So you can either write it per week or per week squared. But basically that's because P of T is a measure of rate. So we're trying to find the rate at which the rate is decreasing. So pounds per week squared. And that's our answer. Alright, that one was a pretty tricky one, but now we're getting back to some easier ones. Number of gallons of water in a storage tank. Gallons of water in a storage tank is measured at T in minutes, so that's our independent variable. It's modeled by WT. Interpret W prime of T 10 equals 8, negative 8. So now Okay, at 10 minutes, because minutes is our independent variable, the amount of water, let me extend this, the amount of water is decreasing at a rate of 8 gallons, that says 9, 8 gallons per minute. And that is our answer. Let's keep going. The rate at which temperature is changing is modeled by T of H. So T of H is the rate at which temperature is changing. Again, we are measuring the rate of change of a rate already, so we're going to have to use per something squared. T is a measure in degrees per hour, and H is the hours since midnight. So hours since midnight is our independent variable. We need to interpret T prime of 20 equals negative 0.5. So at 20 hours, the rate of temperature, let me extend this, temperature change is decreasing at a rate of 0.5 degrees per hour squared. Okay, let's keep going. A harbor water depth changes with ocean tides. The rate of change of depth of water is measured by D of T, where D is measured in feet per hour. So this is what D of T is measuring, the rate of change of the depth per water, and T is the number of hours. We need to interpret it D prime of 2 equals negative 3. So again, our slope is negative, which means it's decreasing. So we can say at 2, let me just extend this, at 2 hours, the rate of the water depth is decreasing at a rate of 3 feet. And remember, we're looking at the rate of change of a rate of change, so we have to say per hour squared. Per hour squared. The height of a rocket is modeled by H of T meters, and it's measuring the height of the rocket, where T is the measurement of seconds. Interpret H prime of 10 equals 30. Alright, so at 10 seconds, the height is increasing at a rate of 30 meters per second. So let's just break this down. 10 is our number here, and seconds is our independent variable. The height, because that's what we're measuring, is increasing because our thing is positive at a rate of 30, which is our result, meters per second. So our dependent per our independent, and that's basically it. I'm not gonna do the last two because they're pretty much the exact same. So that's it for 4.1. 4.1 is a pretty easy unit if you've been following so far and you understand the concept of derivatives. The next unit might be pretty tricky if you haven't taken a physics class. We'll go on to that tomorrow. Leave your questions in the comments, and bye.